So we have understood all the relative speed related concepts that is there to understand, and we have solved some basic questions also, which I hope helped you understand the concept better. Now let's solve some real questions which have appeared in various exams, and through that try to build on the concept further. Okay, so let's get started with this question. Now here in this question, if you see, a train overtakes two people running at 9 kilometers per hour and 18 kilometers per hour in the same direction as itself and passes them completely in 30 seconds and 40 seconds. So there is a man 1, there is a man 2, and there is a train. Okay, they will have the length and they will have the speed. This length, let's say, is L. Train speed also I don't know, so let's say it is S. Man 1 will have negligible length, I can ignore. Man 2 will have negligible length. Man 1 has a speed of 9 kilometers per hour. 9 means 9 into 5 by 18. So it is 5 by 2 kilometers per second. Okay, so kilometer per hour we have converted to meters per second, and the second person is 18 into 5 by 18. So it is 5 meters per second. So this is the data that we have. Okay, so and the time taken to cross man 1 is 30 seconds and this is 40 seconds. Okay, so length is nothing but distance. So using our formula, we know that this 30 seconds is length of the train upon speed of the train minus 5 by 2, minus because they are running in the same direction. And second equation will be 40 is equal to length upon S minus 5, right? These are my two equations. I don't want S, I want L. So one easy thing would have been that I divide both these equations, but if I do that, my L will get cancelled. I'll get S first and then I'll get L. So instead of that, let's cross multiply. So I get 30S minus 15 into 575 is equal to L. And in the second case, 40S minus 40 into 5, 200 is equal to L. And then let's multiply the first one with 4 and the second one with 3 so that my S becomes same. So I have 120S minus 300 is equal to 4L, and 120S minus 600 is equal to 3L. Now I do minus, plus, minus. So this gets cancelled. 300 is equal to L. Okay, and the unit, because speed was in meters per second, length is in meters. So your answer is length of the train is 300 meters. Okay. One more thing we can find out, not required, but for our understanding, is speed of the train. So if I put this L anywhere, let's say I put in this. So L is 300. So 30S minus 75 is 300. So 30S is equal to 375, or S is equal to 375 upon 30. Right? Both are multiples of 5. So this is 6 and this will be 5. So you will have 37. So you'll have 75. Okay. Further, both are multiples of 3. So this will be 2 and this will be 25. Okay. So speed is 25 by 2 or 12.5 meter per second. Okay. So this is 25 by 2. Okay. This is 300. Okay, so that's how this will be answered. So simple question, very similar to what we had done earlier, right? Let's do a slightly higher level of question. And this question is one of my favorites. A train starts from Delhi at 10 AM and reaches Lucknow at 4 PM on the same day. So let's say this is Lucknow, Delhi, this is Lucknow, 10 AM and reaches 4 PM. Another train starts from Lucknow at 12 noon and reaches Delhi at 10 PM. Okay, so this is this direction and this is this direction. At what time will the two trains meet? When will the two trains cross each other? Now the beauty of this question is the amount of data that you have is so minimal. There is no distance, there is no speed, there is no time, nothing. Time is actually there. If you come to think of it, the first train, it starts at 10, reaches at 4, so it takes 6 hours. The second train starts at 12, reaches at 10, so it takes 10 hours. This much data is there. Okay. Distance also I don't know, but one thing that I know is distance is same, so I can assume it to be d. Okay. They are in opposite directions, so relative speed, the speeds will get added, though I don't know the speed. Okay. But I know distance, I know time taken. Distance I don't know the value, but I know at least the distance is d. So for the first train, I can say that the distance is d. So let's say this train, we'll call it train A, and this train we'll call it train B. So train A, train B, both of them cover a distance of d kilometers. Time taken to cover that is 6 hours and 10 hours. Hence the speed I can say is d by 6, distance upon time, and d by 10. So at least I know the speed in terms of d. Okay, so this much data is there. They are moving in opposite direction, so the relative speeds will get added. But one classic mistake that students do while solving this question is, please understand that relative speed can be applied only when both the bodies are in motion. Okay, here if you see, from 10 o'clock to 12 o'clock, only train A moves. Train B starts moving after 12 o'clock, right? So you can't apply relative speed from 10 to 12. Relative speed can be applied only after 12 o'clock when train A is moving and train B is also moving. Okay, so let's say this is 12 o'clock. The train A is here at 12 o'clock. Okay, now you can apply relative speed because train A is moving in this direction, train B is moving in this direction, both of them are moving. So I'll need to know where will train A be at 12 o'clock. 12 o'clock means it has traveled for 2 hours. Okay, so distance will be speed into 2 hours. That means it would have covered d by 3. So d by 3 kilometers is already covered. Distance left now is 2d by 3. Right? 2d by 3, how do I get? D minus d by 3. So d minus d by 3 is 2d by 3. That is the distance left on which I'll apply the concept of relative speed from 12 o'clock onwards. So at 12 o'clock, the distance between train A and B is 2d by 3. Their relative speed is d by 6 plus d by 10. And hence the time taken for them to meet will be distance upon relative speed. This should be my answer, and you can see that d will get cancelled. Okay, so 2d by 3 upon 6 and 10, LCM is 30. Okay, so this is 5d plus 3d. Okay, this is 10. So 20d upon 8d. D is cancelled. 20 upon 8 is 10 upon 4 or 5 upon 2, or it is 2.5 hours, 2.5 hours. 2.5 hours from when? 2.5 hours from 12 noon. Hence, they will meet at 12:30. Sorry, they'll meet at 2:30 p.m. Okay, they will meet at 2:30 p.m. Where will they meet? That also you can find out, not in distance terms, but at least in ratio terms. So in 5 by 2 hours, train A will travel how much? Train A will travel, its speed is d by 6. It travels at a speed of 5 by 2. So it will travel a distance of 5d by 12. And train B has a speed of d by 10 into 5 by 2. It will travel a distance of d by 4. So for B, you get this value, right? You get 3d by 12. Okay. So A is 5d by 12, B is 3d by 12. Together A plus B will be 8d by 12, right? And if you see this distance, this was 2d by 3. Now 2d by 3 is nothing but 8d by 12. They're same. So basically this distance gets divided between A and B in the ratio of 5d by 12 is to 3 by 12. 12 can cancel, D gets cancelled. So basically it gets divided in the ratio of 5 is to 3. Okay. And A had already covered d by 3 first. D by 3 also, if I convert this into the same ratio 12. So basically now 3 parts. First part is d by 3. Second part is 5d by 12. And third part is 3d by 12. Okay, this d by 3 also, I can say this is 4d by 12. So 4 plus 5, 9d by 12 is covered by A, and 3d by 12 is covered by B. So their distance covered is in the ratio of 9 is to 3 or 3 is to 1. Okay, so where will they meet? They will meet at 3/4 of the distance between Delhi and Lucknow towards Lucknow. Okay, 3/4. This distance is 3 times, this distance is 1 time. Now you won't know the exact value because the distance is not known to you, but the whole distance will get divided in the ratio of 3 is to 1. Okay, A will cover 3/4 of the distance, B will cover 1/4 of distance. Out of that 3/4 that A will cover, 1/3 it has already covered before even train B started. Okay, so it's a very nice question which explains to you the concept very simple in a simple manner. Okay, let's look at another very interesting question. Again, this is one of my favorites. A rat saw a cat at 8:30 a.m. and started running. So rat started running at 30 kilometers per hour. Okay, so rat speed is 30 kilometers per hour. The cat noticed this after 2 minutes and started chasing at 36 kilometers per hour. Okay, so cat is 36 kilometers per hour. Okay, at what time will the cat catch the rat? Now this is a very important concept here. The rat ran ahead. Okay. Now if you see how much advantage does the rat have? Rat, when the cat started chasing, when will the cat start chasing him? At 8:32, right? So cat will start chasing at 8:32. The rat would already be at some distance at 8:32. That is the distance between them as per relative speed. So when they both bodies start moving, then the distance between them is the distance that you take in the formula. Okay, fine. So in this 2 minutes, how much distance will be covered? Okay, so now this is minutes, not even hour, not even second. So what do? Let's look at minutes only. The rat is running at a speed of 30 kilometers per hour. Okay, that means half kilometer per minute. If hour I divide, hour I change to minutes, it will be 30 by 60. That means half kilometer per minute. That is the speed of the rat. So in 2 minutes, it will cover 1 kilometer. So the distance between the cat and the rat is going to be 1 kilometer. This part is clear? I've converted it to minutes because my data is in minutes. Obviously, you can do in seconds also, not a problem. If you do in seconds, what will you do? 30 into 5 by 18. This is the speed in meters per second. And then 2 minutes means 120 seconds. So we'll multiply this. So how much do I get? 30. So 10 and 6. And then this is 20. So 20 into 5 is 100. 100 into 10 is 1000. You get 1000 meters, which is same as 1 kilometer. So this is the distance. And then they're running in the same direction. So speed will be subtracted. Okay, so distance is 1 kilometer, and since distance is 1 kilometer, I can take my speed in kilometer per hour only. So 1 kilometer upon relative speed of 36 minus 30. Okay, so I'll get 1 by 6. Time required is 1 by 6 hours, right? 1 by 6 hours means 10 minutes. 10 minutes. from 8:32. That means at 8:42 the rat will be caught. Okay, this is the whole concept. Now just to understand how much distance the cat, so if you understand this, the distance covered by the rat in 12 minutes is same as the distance covered by the cat in 10 minutes, because cat started 2 minutes later, right? Let's see. So the rat is at a 30 kilometers per hour. Okay, so the distance covered, let's understand this. All these are important because there are various ways of doing this question. So the 30 kilometers per hour into 12 minutes, right? But my data is in kilometers per hour, so 12 minutes I'll multiply by 60 so that it converts to hour. Okay, so you will see 12 by 2, it will cover 6 kilometers. So the rat covers a distance of 6 kilometers in 12 minutes. Okay, time. And the cat is running at a speed of 36 kilometers per hour. It runs only for 10 minutes, 10 by 60. Okay, so 36 by 6, that is how much? That is also 6 kilometers. So in 10 minutes, it covers 6 kilometers. Same thing. So at 8:42, the rat will be caught. I hope we are clear with this. Okay, there's another method to look at this. Another concept, though all are finally same, but just understand one more approach, which will be also very helpful, is basically what happens. First, the cat needs to be faster than the rat to catch it, right? If the speed of the cat is same as the speed of the rat, it will never be able to catch, right? Because rat is already, you can see, 1 kilometer ahead, and the cat basically has to cover that gap. It has to cover that 1 kilometer, so it has to be faster. If the speed of the cat is same as speed of the rat, the gap of 1 kilometer will always remain. And if the cat is slower, then actually the gap will increase. So for the gap to decrease, the one who is coming from behind has to come at a faster speed always, otherwise you will never be able to catch up. And the cat is faster. The cat is 36. So another method of understanding this is, and that is what the formula does, but without the formula, if I want to do it from the concept, see, basically the cat, whatever distance rat covers after 8:32, that does not matter to me, because cat will anyway cover that. I just want cat to cover this 1 kilometer, this gap. And this gap, so if you see, rat has a speed of 30 kilometers per hour. Cat also speed of 30, I don't bother, because 30 will cancel, and whatever distance rat will cover, cat will also cover, so that distance will get cancelled. Don't bother about the distance, only bother about the initial distance. And for this initial distance, what I need is the extra speed of the cat. So if you see, 36 minus 30, cat is running at a 6 kilometers per hour extra speed, right? And at 6 kilometers per hour extra speed, to cover 1 kilometer, basically you need, so time required is distance upon speed. Same concept actually, but this is, we are doing conceptually, 1 by 6, that is you need 10 minutes. So 10 minutes is needed by the cat to cover this gap, right? That's all. Don't bother about the distance after this, because that cat will anyway cover. But cat needs to be faster to cover this gap, and this, for this 10 minutes are required. Okay, fine, very nice. Same concept. One more question, and this is I like this question more. Robbers rob a bank at 9:30 am and run away at a speed of 90 kilometers per hour in their car. What is the latest time by which the police can start chasing them at 1:20? So obviously the police have a faster speed, so they'll be able to catch up, but they have to catch the thieves by 11:30. Okay. Now this is very, very similar to the previous question, and both these questions in fact can be done using the concept of relative speed or without the concept of relative speed as well. In fact, the first question, for example, if you want to solve without using the concept of relative speed, okay, think of one more let's try one more approach, very nice approach, that basically the cat runs for t minutes and the rat will run for t plus 2 minutes because the cat started 2 minutes later. So the time they have run is this much. The distance that they have covered is same, and the speed is 30 and 32, 30 and 36. Okay, so the distance covered by the rat has to be equal to the distance covered by the cat. Okay, that's one thing you'll have to be careful. This is kilometers per hour and this is in minutes. So we convert this to minutes. So it is half kilometer per minute. And this 36 will change to 36 upon 60. It will be 6 by 10 or 3 by 5 kilometers per minute. So let's take this. We could have taken meter per second also, but this is also fine. So at this speed, the distance of the rat would be half kilometer per minute into t plus 2 minutes, which will be equal to 3 by 5 kilometer per minute into t minutes. This is also fine. We are just equating the distance because as we did at the start, distance for both of them is same. So when distance is same, then S1 T1 is equal to S2 T2. So this will give me 5t plus 10, okay, is equal to 3 into 2, 60. Hence, t is equal to 10 minutes. My data was in minutes, right? Kilometer per minute. So t is equal to 10 minutes. So this is also fine. So this is 10 minutes and this is 12 minutes. So I have not used the concept of relative speed and I'll get my answer. Okay, so let's apply this approach in the second question. Let's solve it without using relative speed first and then we'll solve it using relative speed. So robbers rob a bank at 9:30 am. The only problem in the second question is we don't know when the police started chasing them. Okay, so let's assume again that the police started chasing them t hours. Let's keep it in hours. Okay, t hours after 9:30. Okay, so robbers ran away at 9:30 am and let's assume they have to be caught by 11:30 am. That means they have run for 2 hours at a speed of 90 kilometers per hour. So the distance covered by the robbers, so we have robbers, their distance is 90 into 2, which is 180 kilometers. Okay, police has to cover the same distance, 180 kilometers. Speed of robbers is 90, speed of police is 120. So time for the robbers to run obviously is 120 upon 92 hours and time for police is 180 upon 120, which is 3 by 2. Okay, so they need 1.5 hours. Hence, if they have to catch them at 11:30, they need only 1.5 hours. That means they should start chasing by 10 am. That's good enough because in 1.5 hours, at a speed of 120, they will cover 180. Robbers also in 2 hours will do 180. So 10 o'clock is the latest time by when police can start chasing them. Very simple. This is without using the concept of relative speed. Here we have found the distance covered. In relative speed, I will not find the distance covered. Instead, what I will do, let's use the other approach where I'll say, okay, now initially, let's say the police started chasing them. So the robbers ran away at 9:30. Police started chasing them at 9:30 plus t hours. So this t hours, the robbers would have covered a distance of 90t, right? Distance is equal to speed into time and t we are assuming is in hours only. So this 90t is the distance if I apply the concept of relative speed. 90t is the distance and both of them are running in the same direction, so the speed will be 120 minus 90 is equal to time taken to catch, and time taken to catch is how much? total from 9:30 to 11:30 time is 2 hours, and whatever hours they start late, that will get subtracted. So this will be your equation. Time they have to catch the robbers is 2 minus t. So this is your relative speed concept now. So this changes to 90t upon 30 is equal to 2 minus t. This is 3. So 3t is equal to t minus t, or 4t is equal to t 2, or t is equal to half. So half an hour. So the police should start chasing them after half an hour. Hence 9:30 plus half an hour, that means 10 a.m. So I showed you both the approaches to solve this question, with relative speed, without relative speed. But in relative speed, what will the distance that you will take? Distance that you will take is the distance between them before both the bodies come in motion. Very important. Because after that, you don't have to worry about the distance. That your relative speed formula will take care of it automatically. Okay, great. Sure. So let's move on. And through this, we have now done relative speed. We have done good number of questions there, and I hope we have covered this concept well and you have understood this properly. So please revise all the concepts of the first class and of the second class. Do these questions and do some more questions so that you are absolutely clear with this. And we will continue with the concept of relative speed in the next class, where we will take up the concept of races and boats and streams. Okay, they both use the same concept of relative speed. Okay, thank you so much.